Today's topic is JEE previous year questions from aldehydes, ketones, and carboxylic acid. So first question is on your screen, and previous year questions that will give you an idea that how can we approach the question, and at the same time we can revise our NCERT textbook. Okay, so question is major product of the following reaction is. What is ALH? IBU twice. What is the full name of this compound? This two for isobutyl aluminium hydride. That is, this is dibyl H. And dibyl H is used for what? It is used to reduce nitriles as well as esters. That is very much given in the NCERT book. So tell me, what is the answer on this of this question? RCN is reduced to, yes beta, RCN. Even SnCl to HCl can be used here. When we use SnCl to HCl, first we get RCH double bond NH, and then on hydrolysis we get RCHO, and this reaction is called Stephan reduction. Called Stephan reduction. Tell me, what about dibyl H? So dibyl H will give again RCHO. Dibyl H will give RCHO, means C option is the right one. Next question. Which compound would give 5-keto 2-methyl hexanal upon ozonolysis? Yes, beta. Upon ozonolysis, which compound would give 5-keto 2-methyl hexanal upon hydrolysis? See, ozonolysis will break carbon-carbon double bond. See, if A is the right option, what would we get? See, CH3, 1, 2, again CH3, this CH double bond O. This is the product of ozonolysis of A. So see, 1, 2, 3, 4, 5, and 6. So it is, see, it is D-methyl 5-keto 3-methyl. For A, it is 5-keto 3-methyl hexanal. But we need 5-keto 2-methyl. So 5-keto 2-methyl. So I think D is the right option. This is the product of ozonolysis of A, and for D, it is CH3. Here double bond, CH3, CHO. That is 1, 2, 3, 4, 5, 6. So it is 5-keto 2-methyl hexanals. That means D is the right option. C cannot be the option. Reason being, in both the cases ketones are formed. Diketone is there. Here again we have aldehyde, but 1, 2, 3, 4. It is 5 keto, 4 methyl. In first case, 5 keto, 3 methyl. In second B case, 5 keto, 4 methyl. And D case, 5 keto, 2 methyl. That means D is the right option. Okay, beta? Wait. Haan, beta. Is it okay? Shall we continue? Okay, next question. Which of the following on heating with aqueous KOH produces acetaldehyde? Yes, beta. If you are on the YouTube, just please like the video. Today we will do 50 questions, 50 MCQs in one go. So be with me. Yes, beta. Which of the following on heating with aqueous potassium hydroxide produces acetaldehyde? Acetaldehyde. Say when in first case, when CH3CH2Cl is treated with aqueous KOH, we get CH3CH2OH, right? In second case, again CH, we get this product, that is ethylene glycol. First case, ethyl alcohol. In the third, so when treated with aqueous KOH, we get CH3CHOH. When two or more that is the product formed. That means C is the right option. Right option is C. Just write the answer if you note this. Increasing order of reaction is one is propanol, benzaldehyde, third one is propanone, and last one is propanone. So see, out of these, and these two, now you know aldehydes are 10 second means aldehydes, they are more out of aliphatic aldehyde and electrophilic nature of carbonyl carbon, and that's why aliphatic aldehyde is more reactive than aromatic aldehydes. Then come to third and fourth. So in third case, yes beta, hello, yes home, propanone, hello, now is it okay? Hello, अभी अभी भी ऐसा हो रहा है? So in case of propanone, there are, on one side there is ethyl group, and on the other side there is methyl group. So steric hindrance decreases. Okay, plus I effect increase, then reactivity will decrease. So that means aldehyde, then propanone, then butanone. That means B option is the correct one. Okay. Now next, the compound A. तो जो पिछले क्वेश्चन थे वो आपको आ गए पूरे? एक मिनट, से पीछे वाला है. हेलो, हाँ, तो बेटा फर्स्ट थिंग इज aliphatic aldehydes. First of all, aldehyde, out of aldehyde and ketones, aldehydes are more reactive than ketones. So first and second, that is propanol and benzaldehyde, they are aldehydes. Propanone and butanone, they are ketones. So that's why first and second is more reactive, and third and fourth. Then we come to next part, that out of propanol and benzaldehyde, propanol is more reactive. Why? Because in propanol it is aliphatic aldehyde, and benzaldehyde it is aromatic aldehyde. So aliphatic aldehydes are more reactive than aromatic aldehydes. Then come to propanone and butanone. In propanone, on both sides there are methyl groups, and in case of butanone there is one ethyl and other methyl. So plus I effect of ethyl is more than methyl, and that's why butanone is less reactive than propanone. So that's what is the order. Means fourth, that is butanone is least reactive towards nucleophilic addition reaction. Then third, that is propanone, and then come to second, that is benzaldehyde, and the last one means most reactive is propanol. So this is the order. Okay, beta. Got it? So now next question, question number 5. Question is compound A in the following reactions is, बेटा कोचिंग ये सामने आपके चल रही है आयुष कुमार और अंजलि, गुड आफ्टरनून बेटा. So now next question is A with reacting with Grignard reagent and then water, and then on heating with concentrated sulfuric acid we get B, and B on ozonolysis, reductive ozonolysis, gives C and D, and C with concentrated KOH and on heating give potassium salt of benzoate and benzyl alcohol. What is the name of this reaction? Obviously this is Cannizzaro reaction, that is disproportionation reaction. So these are the products formed on disproportionation of benzaldehyde. That means C is benzaldehyde. What is C? C is benzaldehyde. Now come to D. D on heating with barium hydroxide, that is just like dilute sodium hydroxide, means dilute alkali, and on heating gives alpha beta unsaturated ketone. So alpha beta unsaturated ketone is formed in aldol condensation. That means this is the aldol condensation product of, this is aldol condensation product of isopropyl, sorry, acetone. This aldol condensation product of acetone. That means D is acetone. So that means C and D, these are the ozonolysis product of B. So just join them together. This is retro ozonolysis. And just remove O. When we remove the O, we will get the alkene, and this alkene is B. So B is this one. So now ultimately we need A. So this B is formed when the concentrated sulfuric acid on heating. That means that is dehydration. So let us say C double bond O, C C H OH, or CH2 C OH CH3 CH3. Am I right? But at the same time we have CH3 MgBr. So CH3 MgBr. So CH2. Okay. That means if C is the right option, we treat it with CH3 MgBr. So when we treat it with CH3 MgBr and then hydrolyze. So what would we get? C6H5 CH2 COH CH3, right? Because CH3 negative, Mg positive. Let's do on next page. C6H5 CH2 C double bond O CH3. When we treat it with CH3 MgBr, what would we get? This is negative and this is positive. Pi electron moves towards oxygen. So we get C6H5 CH2 CO negative, MgBr positive, CH3 CH3. Okay. Now this is on hydrolysis. We get CH6H5 CH2 COH CH3 CH3, and this one with concentrated sulfuric acid on heating undergo dehydration, and we get C6H5 CH double bond C CH3 CH3. That's it. This is the A. And this one, when it is treated with O3 on ozonolysis, O3 and Z and H2O means ozonolysis, reductive ozonolysis. So we get one benzaldehyde and other as acetone. That means this is C and this one is D. Next we have done. So that means C is the right option. This question came in JEE 2020. Got it, beta? Hello. Yes. Understood? Any doubt in it? Yes, beta. See, aldol reaction, Cannizzaro reaction, ozonolysis, even reaction with Grignard reagent, all the reactions are entered in it. Yes, beta. Okay. So let's move to the next question. That is sixth. The increasing order of the following compounds towards HCN addition. So see, HCN addition means again nucleophilic addition reaction. So you know, nucleophilic addition reaction, the activity is proportional to electron withdrawing groups and inversely proportional to electron releasing groups. Electron withdrawing groups increase the reactivity and releasing groups decrease the reactivity. So see, NO2, because reactivity or addition of HCN takes place at CHO. So in first case, OCH3 group is attached. What is the effect of OCH3? Is it plus R or minus R? What is the effect of OCH3? NO2. Again OCH3. NO2. Here OCH3 is at meta position. Here NO2 at ortho position. Here OCH3 at ortho position. Here NO2 at meta position. So what is the effect? Yes, beta. In the order of reactivity. Write the answer. Right answer. Just see what is the effect of NO2 at ortho position, meta position. What is the effect of OCH3 at ortho position, meta position? So see, at ortho position, NO2 has minus R and minus I effect. At meta position, it has minus I effect. At ortho position, it has plus R and minus I effect, but dominating is plus I at ortho position. At meta position, it has only minus I effect. So now, it is most electron withdrawing, NO2 at most electron withdrawing at ortho position. That's why second is most reactive. Second is most reactive. This is increasing order. Second is most reactive. Then come to fourth, and then OCH3 at ortho and meta. At meta position, it is electron withdrawing group. And at ortho position, it behaves as electron releasing group. So third is least reactive, then first, then fourth, and last is second. That means C option is the right one. Okay. Keep in mind reactivity towards nucleophilic addition reaction proportional to electron withdrawing groups and inversely proportional to electron releasing groups. Electron withdrawing means minus I minus R, and plus R and plus I. Next, major product of the following reactions are. This is one of the cross Cannizzaro reaction. 50% sodium hydroxide and 2 aldehydes having no alpha hydrogen. For Cannizzaro reaction, what is the criteria? Aldehydes with no alpha hydrogens. So both are like that only. But this formaldehyde, benzaldehyde is sterically hindered, and formaldehyde has no steric hindrance. That's why it is oxidized. This molecule is oxidized because in Cannizzaro reaction, first of all, OH negative ion will attack. What will happen? Attack of OH negative ion takes place. So obviously OH negative ion will attack on the sterically less hindered aldehyde. So sterically less hindered aldehyde is formaldehyde. That's why attack will take place on this aldehyde. And then next part is transfer of H negative. That is slow step. That is the rate determining step in Cannizzaro reaction. Transfer of hydride ion. That is the slow step and rate determining step. So hydride ion will transfer on this side. Okay. See, sorry, it's like this. O negative, and then hydride ion transfer, that is a slow step. So in this step we get this product, and then transfer of H plus ion, and that is fast step. The mechanism, because acid will lose H negative ion easily, and that will give it to alcohol, alkoxide. So this is the mechanism of Cannizzaro reaction. In this way, first we get formic acid on the with H3O plus. At the end we get formic acid. One of the product is formic acid and other is benzyl alcohol. So C is the right option. This cross Cannizzaro reaction, and keep in mind the aldehyde having theoretically less hindered carbonyl carbon undergoes oxidation. Next question. Compound A, C9H10O, shows positive iodoform test. So positive iodoform test, it is shown by those compounds having COCH3 group or CHOH CH3 group. Now oxidation of A with KMnO4 and KOH gives acid B with one carbon atom less, C8H6O4, and anhydride of B is used for the preparation of phenolphthalein. So you know, for phenolphthalein we use phthalic anhydride. That means acid formed is phthalic acid. Because phthalic acid give phthalic anhydride. So phthalic acid is formed by, see, these two options are removed, because in these cases the groups are at para and meta. Now we have two options, E and D. In both cases groups are at ortho positions, but in first case is aldehyde having no methyl group, is we need CH3CO group, and in this case there is COCH3 group present. So it will give iodoform test. No doubt on oxidation both will give phthalic acid, but first B will not give iodoform test because it has no COCH3 group. It has COCH3 group, so it will show iodoform test, and this is the right option. So D is the right option. D is the right option. Next question. Para-hydroxy benzophenone upon reaction with bromine in carbon tetrachloride gives para-hydroxy benzophenone. First draw the structure. Para-hydroxy benzophenone. So this is para-hydroxy benzophenone. Now on bromination, CO group is deactivating group, because it will show minus R effect, and it is deactivating group. OH will show plus R effect, and it is an activating group. Is an activating group. That's why this activating group will decide or direct the electrophile attack on it. Obviously, OH is ortho-para directing. OH is ortho-para directing. So that's why it will attack, this bromine will attach at ortho-para. Para is already blocked, so obviously Br will be attached at ortho position. So which option is correct? D. CO will not decide because CO is meta directing and deactivating. So if both type of groups are present in the molecule, deactivating and activating, keep in mind activating group will direct the electrophile to attack. Okay. Next, an organic compound with an organic compound neither reacts with neutral ferric chloride solution. Now, neutral ferric chloride solution, keep in mind neutral ferric chloride test is given by phenols. Phenol when react with neutral ferric chloride, it will give violet colored solution. Okay, violet coloration. Okay, and if neutral ferric chloride test is positive, that means it is a phenol. Okay, that means the compound is not a phenol because it neither react with neutral ferric chloride. It will not react with neutral ferric chloride. That means the compound is not a phenol. That means A option is rejected. Straightforward. Now, nor with failing solution. So failing test, failing solution, not with failing solution. That means it is not an aldehyde. Not an aldehyde or ketone. Failing test, it will not show. That means it is not an aldehyde, but it may be a ketone. Then it, however, reacts with Grignard reagent and give positive iodoform test. If it give positive iodoform test, that means this compound should have either CH3CO group or CH3CHOH group. Then it will give positive iodoform test. Then it will show positive iodoform test. Okay. So out of these, it will not have this type of group. Again, this molecule does not have, but in this case, this is the CH3, CHOH, CH3. This type of group is present. That means this is the right option. See, because of the presence of CO, it will react with Grignard reagent, and because it has CHOH group, so it will give positive iodoform test. So D is the right option. Next, the major product formed in the following reaction is, we have dilute NaOH and aldehydes and ketone having alpha hydrogens. The compound having aldehydes or ketones having alpha hydrogen in the presence of dilute alkali, yes beta, it undergoes, yes, what is the name of the reaction? It undergoes aldol or canizer. Aldehyde or ketones having alpha hydrogen in the presence of dilute alkali. Yes. Aldehydes having no alpha hydrogen will undergo Cannizzaro reaction, and aldehydes or ketones having alpha hydrogen will undergo aldol reaction. So this is an example of aldol reaction. So now aldol reaction it will undergo. So tell me, what is the product form? Obviously, in first case, it is alpha beta hydroxy aldehyde, the hydroxyaldehyde, it is gamma. That means this is not the product, maybe the products. Okay. Now next one, alpha beta gamma, not the product. Means A and B, out of these two, we have the product. Now let us say in the first case, CH3 C double bond OH, and second one is benzene ring C double bond O CH3. So one is acetophenone and other is acetaldehyde. So when these two are present, the first case, either we get CH2 C double bond O, this anion, alpha hydrogen is removed by OH negative, or C double bond O CH2 anion. These are the two anions. Now, when this anion what is the role of alpha hydrogen? This is acetaldehyde. When it react in the presence of base OH negative ion, OH negative ion will get this H plus ion, and we get CH2 C double bond OH, because it is resonance stabilized. And due to resonance, it gives this anion. Now this anion will attack on acetophenone as well as on the same molecule. Sorry. Anion along with this we get water. So in the presence of water, it is COH, CH3, CH2, C double bond OH. This is cross product. Beta hydroxy means the benzene ring and CH3. That means B is the right option, because in this case, when we heat it, what is the product form? CH3 double bond CH, C double bond OH. See, it is completely conjugated system. So overall, this is the right option. B is the right option. Okay, major product is B. A is also formed as self aldol. This self aldol product, and this is cross aldol product. This cross aldol product is the major product because alpha beta unsaturated alkene formed in this case is completely conjugated. Next, which of the following compounds will most readily be dehydrated to give alkene under acidic condition? First is 4-hydroxy pentane on pentane 2 on 1 2 3 4-hydroxy 4-hydroxy pentane 2 on 1 2 3 4 2 on and 3-hydroxy. Then 1 pentanol. Last one is 2-hydroxy cyclopentanone. Hydroxy cyclopentanone. Tell me which one is the right option. Most readily be dehydrated. Yes, beta. Can you do it? Most readily be dehydrated. So keep in mind, most readily dehydrated one is this, because when we heat it, this is the alpha hydrogen for it. For this one, this is the is hydrogen nearest to neighboring to OH should be removed. So when it is removed, you will get this product. Conjugated enone, and this hydrogen is out of all these most acidic because it is closer to CO, and CO being electron withdrawing group makes it most acidic. Dehydration takes place under acidic condition, so that H plus ion is removed, which is most acidic in dehydration. Always this is the case, so A is the right option. In second case, no doubt we will get the same product, but in this case hydrogen that should be removed is not as acidic as in 4-hydroxy pentane 2 on, because in this case the hydrogen which is removed as H plus ion is most acidic because it is closer to CO. Next, the reaction. First, what is the name of this reaction? Two molecules of CH3CHO in the presence of OH negative ion will give A, on heating gives B. What is the name of this reaction? Yes, Om. What is the name of this reaction? Which type of aldehyde is this? Having no alpha hydrogen or having alpha hydrogen? So CH3CHO, does it have alpha hydrogen or not? Beta, carbon neighboring to CO is alpha carbon. Is saturated carbon and having hydrogen, so it has alpha hydrogen. In the presence of OH negative ion, it will form this is resonance stabilized, and then this nucleophile will attack on the another acetaldehyde, and we get the presence of water, we will get this product, which on heating OH and H is removed, so we get CH3 CH CH CH. O. CH3, CH double bond CH, CHO means E option is the correct one, and this is aldol condensation reaction. Okay. This is aldehyde with alpha hydrogen, and we get first beta hydroxyaldehyde, which on heating gives alpha beta unsaturated aldehyde. So B option is the correct one. Yes, which one of the following reactions will not result in the formation of carbon-carbon bond? In the Raymond-Diamond reaction, what is the product formed? Phenol on reaction with chloroform, the presence of potassium hydroxide or sodium hydroxide, followed by hydrolysis, we get salicylic or salicylic acid with carbon tetrachloride. So in Raymond-Diamond reaction, there is a formation of carbon-carbon bond, Crittlecraft acylation. Benzene react with acetyl chloride in the presence of anhydrous AlCl3 leads to the formation of acetophenone. Again, there is a formation of carbon-carbon bond. In Wood's reaction, methyl chloride or any halide in the presence of dry ether will give alkane with even number of carbon atoms. That is carbon-carbon bond again formed in all the three A, B, and C. Carbon-carbon bonds formation takes place. Obviously, Cannizzaro reaction is the one in which there is no carbon-carbon bond formation, new carbon-carbon bond formation. Because in this case, we have aldehyde with no alpha hydrogen in the presence of concentrated sodium hydroxide. It will undergo disproportionation reaction, and we get alcohol and sodium salt of carboxylic acid. Disproportionation reaction takes place. No carbon-carbon bond formation. Next one. Yes, beta, understood? So D is the right option. Next. Which is the major product formed when acetone is heated with iodine and potassium hydroxide? First, tell me what is the name of this reaction. This is acetone on heating with iodine and potassium hydroxide, or sometime it is written as KOI, potassium hypoiodide. This is iodoform test, iodoform reaction. In this case, one of the CH3 is giving iodoform, yellow PPT of iodoform, and other part is giving, one CH3 gives CHI3 and other part is converted into sodium salt. Okay, so in this way, this is the major product formed when acetone is heated with iodoform, iodine and potassium hydroxide. So that is only iodoform, right? Formaldehyde can be distinguished from acetaldehyde. Acetaldehyde iodoform test is given by first on in aldehydes only CH3COH acetaldehyde will give iodoform test. Primary alcohol, only one primary alcohol will give iodoform test, and that is ethyl alcohol. All the methyl secondary alcohols will undergo this test, and all methyl ketones undergo this test. So if we distinguish formaldehyde from acetaldehyde, Gibbs reagent test, all aldehydes will give this test. Tollens reagent test for all aldehydes. Failing solution test for aliphatic aldehydes. Aromatic aldehydes will not give this test, but formaldehyde as well as acetaldehyde both are aliphatic aldehydes, so they will give failing solution test. That means these are not the right options. But iodoform test, I2 in the presence of alkali, I2 in the presence of alkali, no reaction in this case, but because it is methyl ketone, this methyl part will give iodoform and rest part will give sodium salt. That's it. That means this is the right option. I2 in alkali. Iodoform test is used to distinguish between formaldehyde and acetaldehyde. Conventional reduction of a ketone is carried out in the presence of, yes beta, conventional reduction. Conventional reduction में क्या यूज होता है? यस बेटा, कन्वेंशनल रिडक्शन में क्या यूज करते हैं हम? याद रखना, जिंक अमलगम इन द प्रेजेंस ऑफ HCl, जिंक अमलगम इन द प्रेजेंस ऑफ HCl, तो ये प्रोडक्ट मिलता है. तो मतलब बी ऑप्शन इज द राइट वन. इसमें तो सिर्फ इतना सा बताना था that what is the reagents used in conventional reduction. Which of the following is the product of aldol condensation? Actually, it is not the aldol condensation, but it is the aldol reaction. First case C, with respect to CO, it is alpha hydroxy, not the aldol reaction. Alpha beta, beta hydroxy may be the right option. Here, alpha beta gamma, not the right product. Alpha hydroxy, not the right product. Only B is the right product formed. Because in aldol reaction, first we get beta hydroxy aldehyde or beta hydroxy ketone. On further heating will give alpha beta unsaturated aldehyde or alpha beta unsaturated ketone. Okay, so B is the right option. Next, mechanism of reaction is not given by. Yes beta, mechanism of reaction is not given by. Mechanism of reaction not given by. Tell me. Mechanism of reaction is not given by. Yes beta. कैनिज़रो रिएक्शन कौन नहीं देगा? See, Cannizzaro reaction is given by those which have alpha, which does not have alpha hydrogen. So in first case, no alpha hydrogen. Second case, again no alpha hydrogen. In third case, there is alpha hydrogen. That means acetaldehyde is not given Cannizzaro reaction. Cannizzaro reaction is not given by acetaldehyde, but benzaldehyde will give this test. Again, next one is the name of this compound. Methyl cyclohexane carbaldehyde. Okay, that will give this test. Formaldehyde will give this test. So obviously acetaldehyde, the one, will not undergo Cannizzaro reaction because it has alpha hydrogen. So it will undergo aldol reaction. Next, iodoform can be prepared from all except, yes, this is the very easiest, very easy question. Tell me. Yes, beta. Which one out of these not give iodoform? The first is ethyl methyl ketone. So this is ethyl methyl ketone. It has CH3CO group. It will give iodoform test. Isopropyl alcohol. It has CH3CHOH group. Will give iodoform test. 3-methyl butanone, 2-butanone. 3-methyl 2-butanone. It has COCH3 group. Undergo iodoform test. But isobutyl alcohol, it has no CH3CO group or CH3CHOH group. That means this is the right option. Isobutyl alcohol is primary alcohol, and only one primary alcohol will give iodoform test, and that is ethyl alcohol. Okay. Next, among the following, the order of reactivity towards nucleophilic addition is, as I said earlier, plus I effect. As plus I effect increases, reactivity towards nucleophilic addition reaction decreases. So see, one is CH3CHO. It has one methyl group, it has plus I effect. Acetone, it has two methyl groups having plus I effect, and at the same time steric hindrance. Its reactivity is proportional to minus I effect or minus R, withdrawing. Inversely proportional to plus I effect, inversely proportional to steric hindrance. So last one is formaldehyde. So obviously formaldehyde is most reactive because it has no group which is releasing the electron towards CO. That's why it is most reactive. And then acetaldehyde, and at the end it is acetone. That means B is the right option. Both plus I effect increases, maximum plus I effect is in acetone. Steric hindrance is also maximum in acetone. That's why it is least reactive towards nucleophilic addition. Next, reaction. What is the name of this reaction? Yes, this you will answer. This question you will answer. Yes, madam. Answer this question. Ohm. Ohm. What is the name of this reaction? We have done just 5 or 10 minutes earlier. Zinc amalgam and concentrated HCl. CH3CHO is converted into CH3CH3. What is the name of this reaction? This is Clemmensen reduction. What is the name of this? Very good. It is Clemmensen. Very good, beta. It is Clemmensen. Yes, yes, right. Tollens reagent and failing solutions. They are used to distinguish between Tollens reagent and failing solution. They are used to distinguish between aldehydes. Give this test, both Tollens test as well as failing solution test. See, yes, beta. Yes, beta. It is ketones and aldehydes, because aldehyde, when they are treated with ammoniacal silver nitrate solution, means Tollens reagent, then yes, it is option C, silver mirror test. Is silver mirror test. H2O and all, they are formed. Okay. Silver mirror test, and because all aliphatic as well as aromatic aldehyde give this test. Ketones do not give this test. Same failing solution test. Failing solution is equivalent mixture of failing A and failing B. Failing A is copper sulfate and failing B is Rochelle salt, sodium potassium tartrate, and that will give RCO negative, Brown PPT. But only aliphatic aldehyde give failing solution test. Even aromatic aldehydes will not give this test. Okay. So ketones do not give this test as well. That's why their Tollens test as well as failing solution test both are used to distinguish between ketones and aldehydes. Next, in Cannizzaro reaction, given below, slowest step is, yes, beta. What is the slowest step in this case? I have written the mechanism in one of the reaction. I'm writing it again. First of all, OH negative ion attacks one of the aldehyde, and we get this product. Then after this reaction, another molecule, this hydride, this electron pair attack, and this transfer of hydride ion is a slow step. Transfer of hydride ion, the carbonyl group, that is the slow step. Then transfer of H plus ion, fast step, get pH C double bond O negative and pH CH 2OH. Transfer of hydride ion is the slow step. Keep in mind. This is the mechanism of Cannizzaro reaction, and in the last step, there is transfer of H plus sign from acid to alkoxide, and that's why this is the first step, because acid give H plus sign and this is acting as base and accept H plus sign easily. That's why it is a fast reaction. But this transfer of hydride ion to the carbonyl group, it is transferred as H negative ion with electron pair. It is transferred. Okay, that is the slow step. Increasing order of the rate of HCN addition to the compound A to D is, yes, very good. That is the right option. Cake maker, what is your name? Increasing order of the rate of HCN addition to compound A to D. The first one is formaldehyde. Second one is acetone. Third one is acetophenone. And last one is benzophenone. But you know, here these are bulky group, but bulkiness increases further in acetophenone, and these are most bulkiest group. Utkarsha, okay. Welcome, Utkarsha. Okay, this is benzophenone. So you know, most reactive is formaldehyde, and least reactive is benzophenone. That means reactivity order is D is least reactive towards this reaction because it is HCN is nucleophilic addition. So benzophenone and then come to acetophenone. Then it is acetone and most reactive is formaldehyde being least hindered and at the same time no releasing group attached. So this A, B, C, D. That means A option is the right one. Okay, which one of the following is reduced with zinc amalgam and hydrochloric acid to give corresponding hydrocarbon? What is the name of this reaction? Now I think those who are connected from the beginning know it is a Clemmensen reduction. And in Clemmensen reduction, aldehyde and ketones, they are converted into alkane. Obviously butane 2-one, the right option because it is a ketone. Ketone that is used to butane 2-one. So butane 2-one in the presence of zinc amalgam and concentrated HCl, we get butane. Option D, very good. Rakarama. Okay. Next, which one of the following undergoes reaction with 50% sodium hydroxide? It is hydroxide. It is hydroxide. 50% sodium hydroxide, and to give alcohol and acid. That means it is disproportionation reaction. And what is the name of this reaction? I think you know better than anyone else. That is a Cannizzaro reaction, and Cannizzaro reaction is shown by those aldehydes which have no alpha hydrogen. Aldehydes having no alpha hydrogen. So which one of them is the one that has no alpha hydrogen? Benzaldehyde. Benzaldehyde and acetaldehyde 3 and formaldehyde. These are two options given in the NCERT under Cannizzaro reaction. Because when benzaldehyde undergoes Cannizzaro reaction with 50% sodium hydroxide, it will give benzyl alcohol and sodium benzoate. Formaldehyde, when undergoes Cannizzaro reaction with 50% sodium hydroxide, it gives methyl alcohol and sodium formate. Right? Increasing order of acidity of the alpha hydrogen of the following compounds. See, acidity increases, or acidity is proportional to electron withdrawing groups. Acidity is proportional to electron withdrawing groups. So which hydrogen or which carbon is attached to most electron withdrawing groups? See, here CO. Carbon, is attached to electron withdrawing groups on both sides. This is most acidic. Alpha hydrogen is most acidic in B. If you compare others, it has plus R effect. This one is also has plus R effect. Both have plus R effect. Here there are methyl groups. Has plus I effect. Right? Plus I effect. So B, then A, then C, and last one is D, because wait beta. Pattern. So it is because releasing groups decreases the acidic strength. Electron donating groups decreases the acidic strength. This is most electron releasing group, and this one less than this, and this is least. So most reactive is B. Alpha hydrogen most acidic is in B, and then A, C, D. That means D, C, A, B. A is the right option. Is there a right option? A. Next, P on treatment with bromine and FeBr3 in CCl4 produce the single isomer, that is C8H7O2Br. C8H7O2Br while heating P with soda lime. You know what is soda lime? NaOH and calcium oxide. Decarboxylation reaction takes place and we get toluene. So to get toluene means it is obviously this product, because when it is treated with Br2 in FeBr3, we get meta product. So we have COH as well as CH3, and CH3 has electron releasing. It is an electron releasing group. It is electron withdrawing group. So which will decide? Obviously CH3. And with respect to CH3, these are the ortho positions, and this is para position. Para position is already blocked. Obviously ortho product is formed. Only single product, single isomer is formed, and with NaOH and CO, this whole COH is removed. We get toluene. That means A is the right option. Okay. Next question. An organic compound A having molecular formula C10H20O2. It was hydrolyzed with dilute sulfuric acid to give carboxylic acid B and alcohol C. Carboxylic acid E and alcohol C. For oxidation of C with CrO3 and H2SO4. That is what? That is Jones reagent. Okay. That produced B. That means in C and B, number of carbons are same. Number of carbons are same. So which of the following structures are not possible for A? So in first case, if we hydrolyze it, what is the product form? CH3, CH2, CH, CH3OH along with CH2OH, CH, CH3, CH2, CH3. So when it is in this case COH, sorry, COOH, CH2, CH, CH3, CH2, CH3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, the blunder. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay. Fluorocarbons are same, but when it is hydrolyzed or it is oxidized, we will not get the same product. That means A option, which of the following structures are not possible, so A is not possible. If we compare this, see, this case, we hydrolyze, we get CH3, CH2, CH, CH3, COOH, and on the other side it is CH2OH, CH, CH3, CH2, CH3. If we oxidize, obviously we will get the same product. Get this C, when oxidized we get this B. What about second? CH3, CH2, CH2, COOH, CH2, 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 CH3. So again in this case 1, 2, 3, 4, 5. How can it be possible? Because there are 1, 2, 3, 4. The option can also not be correct. Maybe if A is the right option, so C can also be not the right option, because there are total 1, 2, 3, 4, 5, 6, 7, 8, only 8 carbons. Just increase 1 carbon on each side. Okay. So that on oxidation give the same product. Same is the case here. So right option is this one, because in this case it is not symmetrically arranged. Ester, on one side there are 1, 2, 3, 4, 5, 6 carbons. On the other side there are 4 carbons. Okay, is equal distribution should be there. Next, major product of the following reaction. Chloroform in the presence of aqueous NaOH. This is Raymond-Timmer reaction. So get this product by this reaction. Then with HCHO in the presence of concentrated sodium hydroxide. What is the name of this reaction? This is from the first chloroform and aqueous NaOH. So we get this product. Now, second is Cannizzaro reaction. So disproportionation takes place. We get these two products. Now, and sorry. One is oxidized, other is reduced. Obviously, strictly hindered is reduced and strictly less hindered is oxidized. So we get formic acid and benzyl alcohol. Then the sodium salt. So we get formic acid and along with this product means OH remains as such, Cl, and this means D is the right option. There are two reactions in this particular problem. First is Raymond-Timmer reaction, second is Cannizzaro reaction. Okay. Major product of the following reaction is, yes beta, it is CH3 CH double bond CH C double bond O CH3 is the major product in this reaction. So keep in mind, lithium aluminum hydride does not reduce carbon-carbon double bond. Lithium aluminum hydride does not reduce carbon-carbon double bond. CH3CH double bond CH CH2OH, the product form, because it does reduce aldehydes, ketones, carboxylic acid, ester, even nitro group aldehyde. Okay, but it will not reduce carbon-carbon double bond. That's why this is the product formed along with ethyl alcohol. That means D is the right option. Keep in mind, carbon-carbon double bond not reduced by lithium aluminum hydride. Major product of the following reaction is this chain, benzene ring, irrespective of the number of carbon atoms, it forms hook, potassium benzoate, always, and other carbon is only benzylic carbon left on the benzene ring. Rest of the carbon is oxidized to carbon dioxide and hydrogen to water. Then it is hydrolyzed. With alkaline KMnO4 we get potassium benzoate, and on further hydrolysis we get benzoic acid. Means A is the right option. Next question. The major product of the following reaction is. So this is something tedious question, because when chlorine in the presence of light reaction takes place, it can give CH2Cl, it can give CHCl2 or CCl3, because it is free radical reaction, which on hydrolysis gives CH2OH, Cl, CHCl2 will give CHOCl, COOHCl, because if more than two or more than two OH are attached to the same carbon, water is removed. So we can get CH2OHCl or CHOCl or COHCl. So see, COHCl is there, CHOCl is there, CH2OHCl is there. So what is left? Is A, B, C. All the products are possible, but because it is written as major product, so middle one, because only one or all three, that is not the case. So middle one may be taken as the major product, so we can go with A option. Otherwise, all the three are possible. Beta, we will continue up to 50 questions. You will watch afterwards. That's why I took time. After physics class only I will start. I have chosen after physics class only because of that, because I need more time, because you are running short of time. You can watch afterwards, okay? An aromatic compound A having molecular formula C7H6O2 on treating with aqueous ammonia and heating forms B. So see, aqueous ammonia and on heating, obviously it will give amide. So first one should be a carboxylic acid. Then compound B on treatment with molecular bromine and KOH. This reaction you might not know because it is in next chapter amine. This is Hofmann bromide degradation. Hofmann bromide degradation. In this case, what happens? CO is removed. Degradation takes place. One carbon is removed. We get C6H7N. Now see C6H7N. That means C6H5NH2 is aniline. So that means we have aniline as the last product. C is aniline. So as C is aniline, so obviously B is benzamide, because on Hofmann bromide degradation, HBD, CO is removed, and then on treatment with ammonia on heating, so carboxylic acid will give this product. So that is A is the right option. The correct decreasing order for acidic strength is, so strength of acid is proportional to electron withdrawing groups. That is proportional to minus I and minus R effect, and inversely proportional to plus I and plus R effect. So keep in mind NO2 minus I effect of NO2 is maximum, then CN, then fluorine, and then chlorine. Obviously D is the right option. D is the right option because nitro most electron withdrawing, then CN, then fluoro, then chloro. Increasing order of acidity, again same. One is nitro. Nitro has minus R and minus I effect. OH has plus R and minus I, but plus R is dominating. Chlorine also have plus R and minus I, but here minus I is dominating. This nothing is written means it is CH3. Okay, so that means it is showing plus I and hyperconjugation. So acidic strength, that is proportional to electron withdrawing groups, inversely proportional to electron releasing groups. So maximum acidic strength is of para-nitrobenzoic acid, then it is chloro, para-chloro benzoic acid, then it is, because out of these two, methyl and OH, both are electron releasing groups, but OH is electron releasing due to plus R effect, and CH3 is electron releasing due to plus I and hyperconjugation. That's why second is more electron releasing than third. So it is third, second, fourth, first. Okay. Next, in the presence of small amount of phosphorus, aliphatic carboxylic acids react with chlorine or bromine to yield a compound in which alpha hydrogen has been replaced by halogen. What is the name of this reaction? C. Carboxylic acid on treatment with red phosphorus. Chlorine, bromine in the presence of red phosphorus. So it will give this product, means alpha fluoro or alpha bromo product, and this reaction is called HVZ reaction, Aldehydes-Zelinsky reaction. This is the last reaction in the NCRT for that electrophilic substitution reaction of benzoic acid. Next, in the reaction, we have CH3COOH. With lithium aluminum hydride, what would happen? Lithium aluminum hydride reduce carboxylic acid to alcohol. Then PCl5, alcohol gets chlorinated, get chlorobenzene. Alcoholic KOH act as a base and undergo beta elimination reaction. So beta hydrogen is removed and chlorine. So we get ethene. Ethylene is the product formed. An organic compound A upon reaction with ammonia gives B. On heating B gives C. C in the presence of potassium hydroxide react with bromine to give CH3, CH2 and H2. Same type of reaction. CH3, CH2 and H2. Bromine and KOH means it is again Hofmann bromide degradation. That means it is CH3, CH2, CO and H2. Right? Then on heating, that means it is CH3, CH2, COOH. When it is treated with ammonia, acid-base reaction takes place, we get ammonium salt. On heating, gives amide, and on Hofmann bromide degradation, we get this product. That means it is option number D. Correct order of increasing acid strength of the compounds. Again, withdrawing group. Look at the withdrawing groups. This is electron withdrawing group. CF3. Os Me is also electron withdrawing group, because it show minus I effect here only, because it is not nearest to pi bond. So it show only minus I, but CF minus I effect of C is more. C is most acidic, then it is B. C, B. Now out of A and D, A, there is only methyl group, release electron, but here there are isopropyl group. So D is more electron releasing than A. Is methyl is less electron releasing, so A comes first and then D. That means A is the right option. Because isopropyl group has more plus I effect. More is the plus I effect, lesser is the acidic strength. More is the minus I effect, more is the acidic. Among the following acid, which has the lowest pKa? Lowest pKa means highest Ka means strongest acid. So out of these, it is strongest, because electron releasing groups decreases acidic strength. Electron releasing group decreases acidic strength. So here there is no electron releasing group, that's why C is most acidic. Methyl, ethyl, isopropyl are releasing groups. Out of this, methyl is least releasing, then come to ethyl and then isopropyl. So this is the order of acidic strength, and strongest acid is formic acid, having highest Ka, so lowest pKa. When CH2 double bond CHCOOH is reduced with lithium aluminum hydride, the compound obtained will be, it is CH2 double bond CH2 CH2 double bond CH, and COOH is reduced to CH2OH. It will not affect double bond. A is the right option. Next question. Cl2 in red phosphorus. Cl2 in red phosphorus. Cl2 in red phosphorus. What is the name of this reaction? HBZ reaction. Just now we have done. It becomes CH3 alpha chloro. Product is formed. Then with alcoholic KOH, beta elimination takes place. With respect to chloro, it is alpha, beta. So it gives CH2 double bond CH COOH. That means C is the right option. Monocarboxylic acids are functional isomers of monocarboxylic acid, RCOOH. See, R, let us say CH2 C double bond O OH, or R C double bond OH. Ether is ROR. At least degree of unsaturation should be same. Amine, again not the right option. Alcohol, not the right option. That means ester is the one only, because it can give HCOOR or R C double bond O O CH3. That means ester is the right option. Okay, Utkarsha, wait. First, I will complete this question. Just 2 or 3 questions left. A liquid was mixed with ethanol. A drop of concentrated sulfuric acid is added, and compound with fruity smell was formed. Obviously, fruity smell is of ester. So, alcohol react with carboxylic acid, give ester. CH3, COOCH2, CH3 ethyl acetate. Yes, this is tedious question for you, but simply just keep in mind the reagents required for the following conversion are, see, we have CN, carboxylic, and ester. This is ester, carboxylic, and this is nitrile. You know, carboxylic acid can be oxidized with lithium aluminum hydride as well as B2S6. Two reagents can be used to reduce carboxylic acid, lithium aluminum hydride and B2S6. But lithium aluminum hydride can reduce others as well, like ester. But B2S6 will reduce only carboxylic. So B2S6 is the better option. So out of C and D, sodium borohydride cannot be used. That cannot reduce anyone. Lithium aluminum hydride here can be used, but here we cannot use it. Reason being, here CN should be oxidized, should be reduced to CHO. Not possible with lithium aluminum hydride. So B2H6 can be used. So first option is B2H6. Because B2H6 will reduce COH, COH2, CH2OH. So this will be okay. Now next, double H, ester can be reduced to CH2OH, but then left cyanide. Cyanide is hydrolyzed with it, so it will give COOH that we don't need. C is not the right option. So what is left? Only last one, because B2H6 will reduce carboxylic acid and SnCl to HCl, that is stiff reduction, that will reduce Cn into CHO. First it gives CH double bond NH, then on hydrolysis it gives CHO, and on hydrolysis ester will convert into carboxylic acid. So D is the right option. Next, increasing order of ease of alkaline hydrolysis for the following. The alkaline hydrolysis of the esters. The withdrawing groups increase the rate of hydrolysis. So NO2 is withdrawing, Cl is also electron withdrawing. But you know, NO2 is more electron withdrawing than chloro. This is electron releasing. There is no such group. So that means third is most reactive, then comes second, afterward it is first and then fourth. Third, second, first, fourth. That means D is the right option. So keep in mind rate of alkaline hydrolysis that is proportional to electron withdrawing groups. Okay, in the given transformation, which of the following most appropriate reagent? See, double bond remains as such. COCH3 converted into CH2CH3. That means it may be Elmenson or Fulkushner. But at the same time, it has OH, acid sensitive group. So zinc amalgam cannot be used. So we use NH2NH2 OH negative, means Wolff-Kishner reduction. A is the right option. Arrange the following leveled hydrogens in decreasing order of acidity. So see, most reactive is COOH. Carboxylic acid is more acidic. See, what is the order? Carboxylic acid, then phenol, and then acetylene. That means second is most reactive. Then come to third and fourth, and then first. Now out of third and fourth, NO2 is electron withdrawing group. It withdraw electrons from ortho and para position more than meta, because at meta there is only minus I effect, but at ortho, sorry, at para there is minus I as well as minus R. So third is more acidic than fourth. Then first is second, third, fourth, first. Second, third, fourth, first, means C is the right option. That's it. So total 50 questions we have done today. And if you solve all these questions, definitely you will get few questions out of them in NEET and JEE exam. Okay, now question of Darsha. Ozonolysis of an organic compound gives formaldehyde. Formaldehyde acetone of products. So what is acetone? Acha, it gives formaldehyde as one of the product. If formaldehyde is one of the product here, that means it is terminal alkene. It confirms that it is the terminal alkene. Darsha, got it? As and one you have written as on. So question is, ozonolysis of an organic compound gives formaldehyde as one of the product. That indicates that it is a terminal alkene, because one of the product is CH2 double bond O and other is whatever it may be. Okay, so one of the product, if it is formaldehyde, then it is a terminal alkene. His double bond is at the end of the chain, carbon chain. Got it? Yes, Utkarsha. Yes, beta. Got it? It means one of the double bond, his double bond is present at the end of the chain. So be in touch for NEET and JEE preparation. Share this video with your friends. Ask them to join that live session so that they will also be benefited and prepare well for JEE and NEET exam. Hope you will qualify the exam and support my channel. Like the video. There are many more videos of for JEE and NEET can watch them and get benefited, and just share my channel with your friends that they will also join. Okay, so thank you so much to all of you who like, subscribe and share my channel to all your friends. Thank you so